Hello and welcome to the Math by Matthew virtual homework help class this Tuesday, August 14th at 4 p.m. We are coming to you live from Tucson, Arizona, and today we'll be answering as many of your questions as possible. Thanks again for taking the time to join us today. To get your questions answered, Paul will be communicating with you directly through the Zoom chat. The Zoom chat is located at the bottom of your screen. You may even need to move your mouse a little bit to be able to see that. We're going to start today by taking a look at the question of the day. This question offers daily practice and is a tune-up for college entrance exams like the SAT and ACT. This question and its full solution can be found on the Math by Matthew website at www.mathbymatthew.com. A new question is posted every day with the full Math by Matthew method explaining how to solve it. Let's take a look at today's question. Today's question says, if log base 4 of b equals negative 1.3 and log base 4 of s equals 2.3, what is the value of log base 4 of 256 b to the 5th s to the 4th? The answers are provided there. We know it's some sort of a decimal. We have to be able to break apart log base 4, 256 times b to the 5th times s to the 4th. To do that, we're going to use the property on the right here that log of a times b equals log a plus log b. However, you'll see that there's both a number, a letter to an exponent, a letter to an exponent here. So really the property is log of three things, a times b times c, and textbooks don't usually include this, but it's log a plus log b plus log c. So we're going to use that to break apart the expression on the left. We have log base 4, 256, plus log base 4 b to the 5th, plus log base 4 s to the 4th. The next thing we can do is break apart log base 4 of 256. We know that 256 is 4 to the power of 4. It's really important to know your exponents when you're taking the standardized tests because they allow you to shortcut your time to get the problems done. They know that it takes a while to calculate this by hand, so if you know this ahead of time, it just saves you a ton of time. The other sort of hint here is that this 4 had to match this 4 here. So that's a way to shorten up your time. Log base 4 of 4 to the 4th plus log base 4 of b to the 5th plus log base 4 of s to the 4th. We can now use the property that log base b of x to the n equals n times log base b of x. Basically, we take that exponent n, and it comes out in front. 4 times log base 4 of 4 plus log 5 log base 4 of b plus 4 log base 4 of s. Sometimes I make my s's cursive because I want to differentiate them from the letter 5. Okay, so we're down to this step here where we have to also use a property of logs, which is the log base b of b. If these are the same, this equals 1. So an example of that here we see is log base 4 of 4, that equals 1. So this is 4 times 1. We know from the given information that log base 4 of b is minus 1.3. And we know that log base 4 of s is 2.3. Now we have to calculate these. So it's 4, 5 times negative 1 is negative 5, 5 times 0.3 is 1.5, so it's minus 6.5, plus 8, 4 times 0.3 is 1.2, this is 9.2. So these two give you minus 2.5, plus 9.2. It ends up giving you 6.7, and you can see that the correct answer is A if you scroll back and look at the question there. So we know the answer is A, and that concludes the question of the day. This is a great time to remind everyone that you can find the question of the day by going to the Math by Matthew website. That's at www.mathbymatthew.com. The question of the day tab, you click on it, and you'll see this same question here available as a download by PDF. It also contains the full Math by Matthew method, which is the solution down here on page 2. This question is a daily tune-up for college entrance exams like the SAT and ACT. If you already solved this question and you want a little bit more practice, go ahead and choose our practice materials. We sell a question of the day practice book, which has a lot more questions and full solutions available for practice. All right, let's switch back to answering some more questions. I see that some people have started entering the room. Again, I'll just remind you that Paul will be communicating with you directly through the Zoom chat. And if he does communicate with you, please answer his questions. He just needs to gather information so that we can get your question on screen. So it doesn't look like we're quite ready for another audience question. Let's talk a little bit about logarithms and some of their properties. A lot of people start by learning the properties of logarithms from exponential functions. So an exponential function is a growth function. Exponential functions, they can either grow or decay. We see an example of a growth curve here. A decay curve down here looks something like this, where it's decaying. So this is growth, top here, this is decay. And they're related to logarithmic functions because of the inverse relationship between the two of them. So if you're not quite sure what I'm talking about, this topic is sometimes covered in Algebra 2. It's definitely covered in pre-calculus. But if we look at a function, say a function that is 2 to the x, which is an exponential function, it's a growth function, it is related to log base 2 of x as its inverse function. There's also the growth function e to the x, and it has a related inverse function of the natural log of x. A lot of times this chapter in your textbook starts out by showing you graphs, and you have to be able to graph both growth and decay functions of exponentials as well as logarithmic growth and decay of that function there. The properties that are kind of interesting to use of logarithms, there's quite a few of them. Definitely good idea to look at and have a handy reference available. For example, we've already mentioned that the log of a times b equals log a plus log b. There's also the property that if you have log a divided by b, this equals log a minus log b. So the only difference is that subtraction symbol there. One of the things that I'm not showing you is I'm not showing you the base here, and that doesn't actually change this at all. Let's say it's log base 3 of x times y. Well, this is log base 3 of x plus log base 3 of y. If I say log base 2 of 4 divided by x, this equals log base 2 of 4 minus log base 2 of x. Because it's subtraction, because it's division, you get a subtraction symbol here. We remember from the practice problem, the question of the day, that this can be written as log base 2 of 2 squared. And then this 2, the exponent can come out in front. So it's 2 log base 2 of 2 minus log base 2 of x. And then this part right here, because log base b, whenever the base is the same as the thing you're taking the log of, whenever those are the same, it always equals 1. This is 2 times 1, which is 2, minus log base 2 of x. So sometimes you get some questions where you're actually able to simplify the logarithm down into a number. Looks like we might be ready for that question from Chris R. in Tucson. All right, so it looks like Chris has a question on binary numbers. Chris, please communicate with Paul directly through the Zoom chat. I'm going to take an opportunity here to show everyone how to schedule a one-on-one lesson. We're doing everything through the website now, which is very different than before. Again, if you go to mathbymatthew.com, we've already talked about the question of the day. What we're doing today is under Meet with Matthew. It's our virtual homework assistant or virtual homework help. When you click here, it'll give you the dates and times that we're doing this class. It is free. If you are looking for one-on-one instruction, go ahead and click on private tutoring. We have two options here. We've got traditional one-on-one lessons, and then we've also got the college test prep package, which includes a lesson and our own study materials. These are some of the question of the day materials and our practice book materials and some other things. When you choose the one-on-one lesson, you get to specify your time that you prefer. So the calendar comes up and you can see, like today, as early as today, you can schedule a lesson at 7, 8, 9, 10, or even 11. After you choose your time, you click on continue and it'll prompt you for some of the booking information that we need. So again, that's under Meet with Matthew. And just as a reminder, if you've already done lessons with me, or if you want to schedule time that's not available, just contact me directly. I'll do my best to accommodate you in my schedule. All right, it looks like Chris is going to ask some questions about binary numbers. While he's getting that going, I'm just going to remind everyone that we work in the base 10 number system. A lot of people don't even realize that, but we're in the base 10 number system. When we talk about things like time, time is in a different base altogether. I mean, we don't stop at 10 like we do in the number system. We stop at 12 and then we go back to 1. That's a little bit different. The most common numbering systems that are used in computers is the binary, which is ones and zeros, and then hexadecimal. Okay, so there's a lot of math classes out there, and then there's computer science classes, and there is some overlap here. You know, we're in math classes, and then you got your computer science classes. So we still cover this as part of the Math by Matthew virtual homework help. So feel free to ask your questions in your related field. Hey, Christopher R. Hey, Christopher R.
Hi.
Hey, you got a question on binary number systems. Can you give that to me here live?
Can I share my screen?
No. Are you able to send a picture to Paul directly through the chat, or can you email it to us?
I'll try to email it.
All right. So our email here is learning at mathbymatthew.com. I probably should type that just to make it even more clear here. So if you ever need to get in touch with us through this exercise when we're doing the virtual homework help, we would prefer that you use the chat, but you can always email us directly at learning@mathbymatthew.com. All right, so the way the base 10 numbering system works is number 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we restart. We go back to 0. So actually, I actually need to throw in a 0 here. Let's go actually get the eraser out. Let's erase that, and let's go back to this here. So we start at 0, so base 10. And when we get to 9, we put another digit here in the left position, we go back to 0, and everyone knows that that's 10. Well, in base 2, you're going to see some similarities to start with. So 0 is still 0, and 1 is still 1. But 2 is not 2. And this is where it gets really confusing. So if you recall from the left here, we went 0, 1, 2, 3, 4, all the way up to 9. Because it's base 10, it really ends at 9. Well, base 2 ends at 1. So that means when you get this 1, the next one has to be a 0, and we put a 1 here. So 2 in base 10 is really, it's stated as 1, 0. So in base 2, you don't say 2, and you don't say 10, you say 1, 0 to represent the number 2. You increase the number in this position right here, 0. So that's 1, and then you keep this one. So 3 is said as 1, 1, not as 11, not as 3. It's pronounced 1, 1. So as we mentioned before here, this 1, when you increase it, it can't go to 2. It has to go back to that number that we started with, 0. But you're carrying a number in this next position, so it too goes to 0. And you end up getting 1, 0, 0, 1, 0, 0. And base 2 is 4 in base 10. 5 is 1, 0, 1. See how I'm always increasing this position. And sometimes it carries over into the next one. So when I try to increase this position, it goes to 0. A 1 goes there because there was a 0 up there, and then another 1 here. And this is pronounced 1, 1, 0. So 7 is 1, 1, 1. 8 has the problem like we had when we went to 3 to 4. When we increase this first position, it ends up going up to 0. That carry comes into the second position. Well, it goes to 0. Another carry becomes 1. 9 is 1, 0, 0, 1. And 10 is one of the easiest ones to remember because it really is 10, 10, but it's stated as 1, 0, 1, 0. Hey, Christopher R.
Hi.
Hey, were you able to get that question to Paul?
Yes, well, I have.
Awesome. I'm going to check and see if he's got it up on my side. Great, he does. So we're going to get your question answered here. Tell me, what kind of class are you taking?
Software and app design.
Software and app design. And what grade are you in?
Ninth?
Ninth grade. Okay, that's pretty cool. I don't remember doing software and app design in ninth grade, so you're way ahead of the curve here. Ooh, I didn't expect that. Let's undo that. Let's see if we can copy this in. Copy and paste. All right. For each of the binary numbers, give the values in decimal numbers. Okay, so letter A, 1, 0, 1, this 2, this little subscript here, that means it's in base 2. Is that clear, Chris?
Yes.
All right, now, if we just scroll up, you're going to tell me that 101 in base 2 is 5 in base 10. Do you see that from this chart up here?
Yes.
So we know the answer is that this is 5, and we put a 1, 0 there to represent base 10. The question is, though, how did we get that from this? Now, you could just look it up in a table. Would you agree with that?
Yes.
That works really well for homework or if you're just curious about the subject, but there's an algorithm to do this, and that's probably what your instructor was trying to accomplish in classes, to explain how to do this. So it's a little bit odd, but I'm going to write the number 101. This is the 2 to the 0. This is 2 to the 1, and this is 2 to the 2. Okay, so these are your exponents. So you take this top number, 2 squared. Do you know what 2 squared is?
4.
4, and you multiply it by this bottom number 1, plus 2, because 2 to the power of 1 is 2, times 0, plus 2 to the 0, which is 1. Let me erase that. Times this 1. So this gives us 4 plus 0 plus 1, which is 5. So let's try the next one there. So the next one is 1011. 1011 in base 2. So what I suggest doing is writing 1011, and then above it, you're going to write 2 to the 0 on the rightmost position, 2 to the power of 1 in the next position, 2 to the power of 2, 2 to the power of 3. Chris, what would go in this position that I'm pointing to based on this pattern here? 0, 1, 2, 3, 2 to what power? 2 to the 4th.
Yes.
All right, so you can see how that increases each time. We don't need that for this one. Now, this is kind of the hardest part here, is you have to now multiply these together. So it's 2 to the 3rd, that's this one, times 1, which is that one. You can see where they came from, plus 2 squared, that's this one I just circled, times 0. You can see where that came from, plus 2 to the 1 times 1, plus 2 to the 0 times 1. So we break this number apart into this multiplication and division. 2 to the power of 3 is 8 times 1, plus 4 times 0, plus 2 times 1, plus anything to the 0 power. That's a property. So any number to the 0 power is always equal to 1. It's a property. So this is 1 times 1. So we've got 8 plus 0 plus 2 plus 1, and this equals 11. So this number is written as 11 with a little 10 there. That's 11 base 10. Chris R., is this helping you out here today?
Yes.
That's great to hear. So what I'm going to do here is I'm going to mute you, Chris. I'm going to work through your last question, and I appreciate you taking the time to stop by today. But go ahead and keep watching, and you'll see we'll work out part C here. Okay. All right, part C. The last question you have, it's 1, 0, 1, 0, 1. 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the power of 4. Now, when you're really fast, you'll start writing, I'm going to write the number again here, 1, 0, 1, 0, 1. This is a little bit more advanced technique. You start with 1, 2, 4, 8, and 16, and that's your multiplier. So it's 16 times 1 plus 8 times 0 plus 4 times 1 plus 2 times 0 plus 1 times 1. 16 plus 0 plus 4 plus 0 plus 1. This is 21 or 21 base 10. Another thing to remember is that there's a ton of calculators, online calculators out there right now that'll help you go back and forth between binary and base 10. All right, well, I appreciate everyone coming out today to take part in the virtual homework help. This is a free service that we provide. We really take pride in being able to answer your most challenging question. We know this is a great way to help students, and feel free to check us out at our next virtual homework help, which is tomorrow, Wednesday at 4 p.m. and that's Arizona time, which is currently in Pacific time for those of you on the East or the West Coast. That's all I have for today, and I appreciate your time.